Today we're digging into NVIDIA's new AI model, Nemotron 3 Super, and this one is interesting because it signals a huge shift in how we're building these things. It's not just about getting bigger anymore, it's about getting way faster.
So let's start with that exact question. For the last few years, the AI race has felt like a heavyweight boxing match. Who can build the biggest, most powerful model? But what if that's not the whole game? What if the real breakthrough is all about efficiency?
And that really gets to the heart of the biggest problem in AI right now. You've got this constant tug of war between raw power and real-world speed. It's a trade-off, a balancing act that really defines what these models can and can't do for us.
Okay, so to get this, you need to know about the two main ways to build these AIs. First, you've got your dense models. The best way to think of these is like a giant sledgehammer. I mean, it's super powerful, but you have to swing the entire thing for every single task, no matter how small. So yeah, it's slow and it's expensive. But then you've got mixture of experts, or MOE models. Now these are way smarter. They're more like a team of specialists. A problem comes in, the system figures out who the right expert is, and only that part of the model gets to work. Much more efficient.
And that team of specialists idea, well, that's exactly where NVIDIA is planting its flag. So let's see how they're tackling this whole power versus speed thing. Say hello to Nemotron 3 Super. NVIDIA built this thing from the ground up with one goal in mind: break the trade-off. They wanted to deliver absolutely massive power, but without the insane cost and slowdown you'd normally expect. And when I say massive power, I'm not kidding. The whole model has a staggering 120 billion parameters. That's the sledgehammer, right? That's all the potential knowledge and power packed into this thing. But here's the kicker. This is where the magic happens. For any given task, at any given moment, it only actually uses about 12 billion of those parameters. So think about that. You get the brain power of a huge 120 billion parameter model, but with the speed and cost of a much smaller one. That is MoA efficiency right there.
So you're probably wondering, how do they pull that off? Well, it comes down to a couple of really clever innovations. The first one is a smarter way to manage that team of experts. It's something they call latent MoE.
So what is latent Mo? Well, put simply, instead of sending the full, big, messy problem to its experts, the model does something smart first. It compresses all that information down into a much smaller, tidier package, this latent space. And then it sends that little package to the right expert. And you can see the difference right here. On the left, a normal Mo model is trying to shuffle these huge, clunky pieces of data between its experts. It's a traffic jam. But on the right, you see latent Mo. It squishes the data down first. That one simple step completely changes the game. It slashes the internal data traffic, frees up a ton of resources, and just lets the whole system run so much faster.
All right, the second big trick up its sleeve isn't about how the model thinks, it's about how it talks, or maybe more accurately, how it generates its answers. It's a cool technique designed to speed up the output. It's called multi-token prediction, or MTP. Now, most models work by figuring out the very next word in a sentence, then the next one, then the next. MTP is different. It's trained to predict a whole bunch of words all at once. It's almost like it has a little crystal ball, or like an internal drafting model that's sketching out the next few phrases for the main model to just quickly check and approve. And does it work? Oh yeah, this chart is awesome. It shows what's called the acceptance rate. Basically, how often the model agrees with its own predictions. And you can see it clear as day. Nemotron 3 Super, that blue line, is way better at guessing its own future words than the competition. And it stays better even as it tries to predict further and further ahead. So what does that mean for you, the user? Pure, unadulterated speed. Look at this graph. Turning on MTP gives you this massive jump in performance. You're getting way more words, or tokens, per second without any extra waiting time. It's taking that smarter prediction and turning it directly into a faster experience. It's just brilliant.
Okay, so let's put it all together. You've got latent MoE making the thinking part more efficient, and you've got MTP making the output part faster. So what happens when you pit this thing against its rivals? How does it actually perform? And here we go. This is the showdown. On the left, we've got accuracy scores on a bunch of standard tests. On the right, we've got throughput, which is just a fancy word for raw speed. Nemotron is the green bar. Just take a second and look at how it stacks up. I mean, the key takeaway from NVIDIA's own report really says everything you need to know. They found it has comparable accuracy to the other big models, but with up to 7.5 times higher inference throughput. That's not just a little bit faster, that's a different league entirely. Just to really hammer this point home, look at this chart. If we set a big competitor, GPT-OSS, as our baseline speed of 1, Nemotron is clocking in at 2.2, more than double the speed. And look at that other model, Quen, way down at 0.3. The gap is just enormous. It's not even a fair fight.
But this whole story isn't really just about one company building a faster model. It's about what this new kind of efficient technology means for everybody. And on that front, NVIDIA is making a really big statement. They're not just releasing the model, they're opening up the whole toolbox. We're talking model checkpoints, the actual datasets they use for training and fine-tuning, even the learning environments. They're basically handing over the keys to the entire AI community. And they're putting it all on Hugging Face, which is pretty much Grand Central Station for AI developers. This is huge. It means any developer, anywhere, can now grab this incredibly efficient technology and start building the next cool thing with it. So what's the endgame here? What are people going to build? Well, the report says the model was designed specifically for something called agentic reasoning. All that really means is building AI agents that can do things, think for themselves, use tools, write code, and complete complex, multi-step jobs all on their own. And that leaves us with a really big final question. We've seen AI get bigger, we've seen it get smarter, but what happens when it also gets fast enough and efficient enough to power autonomous agents absolutely everywhere? That right there might be the leap that truly changes everything.